In this lesson, we will continue to examine key questions when representing a business workflow in DAML. In particular, we will be looking at how DAML represents the consequences of decisions, as well as how it manages visibility and privacy of both decisions and their consequences. When we reconsider business workflows from first principles, we see that it consists of a number of events that are the result of people making decisions that have consequences that are observed by people, authorizing them to make more decisions resulting in more events. Events, people's decisions, consequences, observation, authorization. These are the fundamental building blocks of a distributed workflow, and at the center of them is making decisions. So, at the center of each workflow is a loop of people, decisions, and consequences, hopefully continuing until it reaches a desired goal. A distributed workflow is one where the decisions being made and their consequences are no longer neatly confined to a single person, team, or organization. Instead, they require coordination, verification, and rules. So, as we design a DAML workflow, we focus on understanding the decisions that make up the workflow. Analyzing each decision, we will keep coming back to the same set of key questions to characterize and understand them. What was the decision? Who made the decision? What was their role in making this decision? Who authorized them to make the decision? What are the consequences of the decision? Who has a right to be notified of the decision? And who needs to be notified of the consequences of the decision? It can be tempting to immediately jump to questions about static data, fields, records, and in a non-distributed system, these can be useful ways to structure our analysis. However, with distributed workflows, this is a trap. Workflows are fundamentally dynamic. It is important to start by understanding the dynamic activities first. It is the structure of these actions, what they are, and who is performing them that needs to structure your analysis and design. Only once you understand that structure can you consider the static targets of those activities, the things being acted upon. Part of the power of DAML is that it provides first-class representation for each of these concepts. What we have so far is a way to answer the questions: what was the decision? Who made the decision? And who authorized the decision? In DAML, potential decisions become choices on active contracts, and making a decision is represented by exercising one of those choices. Similarly, that exercise is the result of a command submitted by a user acting as a party, so the answer to who made the decision is represented by that controller party. Finally, the authorization to make the decision is associated with the active contract itself. A contract can only exist if it has been signed by a set of parties who become the signatories of that contract. The choices enabled by a contract are authorized by those signatories. So the question who authorized the decision is represented in DAML by the signatories on the contract the choice was exercised on. We see that several core concepts in DAML are directly associated with representing decisions: the exercise of a choice, the controller party, and the signatory parties. We have answers for the first 4 questions, so now we will look at the last 3. We should expect that in a business workflow, the goal may include physical consequences. One example might be: there is now 80 tons of Grade A topsoil at the Baker Street construction site. Of course, as a digital information system, we don't deal with physical items directly. We act a step removed from such things, dealing only with claims and assertions, with the information about the physical item. So in DAML, our focus is reaching and recording consensus on facts, specifically agreement on the current state of the business or on future obligations. So our example becomes: everyone agrees there is now 80 tons of Grade A topsoil at the Baker Street construction site, so we can go ahead and pay for it now. So in a DAML system, the consequences of a decision or choice are one or more of the following: The authorizers and the decision maker, in DAML terms, that means the signatories and controller, jointly authorize someone to make a future decision, jointly agree between them that a new fact is true, and jointly agree between them that a previously agreed fact is no longer true. Now, if we consider our landscaping example, we have Alice, acting for Acme Construction, accepts an offer by Bob. Bob is acting for Lando's Landscaping Supplies to sell 80 tons of Grade A topsoil for $2,000. The topsoil is to be delivered to the Baker Street construction site. When we break this down, we have the decision maker, which is the user, Alice, when Alice accepted the offer. The role in making the decision Alice was acting as, which is the party Acme Construction, in the role of purchaser. Authorization to make decision. Alice was authorized to accept or reject the offer when it was made by the user Bob, and the role that authorized this decision. Bob was acting as the party Lando's Landscaping Supplies in the role of supplier. Of course, we have to consider the consequences, which include Acme Construction and Lando's Landscaping Supplies agree to the sale of 80 tons of Grade A topsoil for $2,000. They also agree that Lando's Landscaping will deliver 80 tons of Grade A topsoil to Baker Street, and Acme Construction agrees to transfer $2,000 to Lando's Landscaping Supplies. If we were focused on the static data associated with the workflow, the temptation would be to stop here. We might think, we have our record, surely we can just store it in a database somewhere, and we are done. But stop and consider this in terms of decisions, and it becomes clear. We haven't yet identified any new decisions authorized by this decision, and without new decisions, the workflow stalls here. When we reconsider the consequences in terms of decisions, we can flesh out the workflow. There is still the base agreement, the contract of sale. Acme Construction and Lando's Landscaping Supplies agree to the sale of 80 tons of Grade A topsoil for $2,000. But from the perspective of a DAML workflow, this isn't the really interesting bit. What is interesting is, who is authorized to attest to the delivery of the topsoil when it eventually happens? And who is authorized to accept and acknowledge delivery of the topsoil when it is received? These are questions about trust, authorization, and the critical decisions people need to make. Decisions that, when represented explicitly like this, could automatically authorize the transfer of $2,000 to settle the account. Now we have an interesting distributed workflow. By thinking in terms of decisions and actions, we keep front of mind that someone has to be authorized to attest to what has happened in the external world. Moreover, that the act of attestation is itself a decision. As a multi-party business workflow, we are no longer in a single data silo with shared trust where the two parties can rely on shared policies or appeal to a common manager to resolve disagreements. If we need to know about the state of the world, we need to identify who each relevant party trusts and authorize them explicitly to attest to this. Acme and Lando have a business relationship, but to automate the workflow, they need more than a handshake to validate and guarantee the rules of their agreement are followed correctly. This is where DAML comes in. In DAML, exercising a choice on an active contract results in a transaction on the distributed ledger. The process of successfully writing the transaction to the ledger involves providing a guarantee that every stakeholder to the transaction has complied with the rules, has had a chance to verify this for themselves, and has agreed that the rules were followed. Without going into too much detail, a DAML transaction contains the exercise, which choice was exercised, on which contract, by which party, new active contracts that were created as a result of the choice, previously active contracts now inactive as a result of the choice. We call this archiving the contract. So returning to the question, what are the consequences? In DAML, all of the consequences we discussed end up being represented by the contents of the transaction, so by the creation of a new contract or the archiving of an old one. Fortunately, because contracts come bundled with choices, this is enough to represent everything we need. We mentioned there were 3 consequences to consider in DAML. First, the authorizers and the decision maker can jointly authorize someone to make a future decision. In DAML, this is represented by some subset of the signatories and the controller becoming signatories on a newly created contract where the authorized party is a controller on a choice. Also, the authorizers and the decision maker can agree between them to attest that a new fact is true. In DAML, this is represented by some subset of the signatories and the controller becoming signatories on a newly created contract that represents a statement of fact. Also, the authorizers and the decision maker can agree between them that a previously attested fact is no longer true. In DAML, this is represented by some subset of the signatories and the controller jointly archiving the active contract that represented the old statement of fact. And so we find 2 more core concepts in DAML directly associated with representing decisions: creating contracts and archiving contracts. Ultimately, even when dealing with facts, it is rarely the fact itself that is important. At the very least, when recording a fact, we have to consider who has the authority to retract or alter that record. This is an example of something that is often ignored or hand-waved away in centralized applications. In a distributed multi-party workflow, it is of vital importance to consider who has to agree about a fact, and under what circumstances can someone change that record. Ultimately, all consequences end up being about enabling future decisions. Even in the case of recording a simple fact, we are still faced with defining how that record can be legitimately changed or retracted. The consequences of a decision in DAML are the creation of a contract that now authorizes a choice be made in the future, or the archive of a contract that retracts a previously authorized choice. In a traditional business system built on a traditional database, creating or archiving a contract would instead be inserting or deleting a record. Our focus would then be on the data being updated or deleted. In a DAML system, the insertion or deletion of data on the ledger is a secondary concern. What really matters is who authorized the update and what future decisions have been authorized or deauthorized as a result. So we can now answer how to represent several DAML constructs. An available decision. This is a choice on an active contract. A decision being made. This is an exercise on an active contract. The authorization required to make a decision. These are the signatories on a contract. And the consequences of the decision. Contracts are created and archived. We are now left with the final question: who needs to be informed? In a traditional system, we would probably talk about read permissions or access controls, but these presume a mutually trusted mediator who can enforce these policies. However, these are distributed workflows, and a critical distinction that characterizes them is that there is no one who can provide this. So, instead of permissions or controls, we have to think in terms of privacy. Rather than who has permission to access, instead pose the question who gets to be informed at all. Authorization and privacy are 2 of the most difficult problems to solve in any distributed system. Fortunately, distributed workflows are DAML's reason to exist, and we have just seen how it handles authorization. It should come as no surprise then that DAML is also a powerful tool for handling the privacy aspects of a workflow. DAML specifies a strict need-to-know approach to privacy. Privacy is a complicated and subtle problem to solve, and the precise specifics of what the DAML ledger provides and how it operates are commensurately complex. We recommend that your senior technical staff review the detailed ledger model documentation available online. For the purposes of analyzing and describing workflows, though, the general privacy principles suffice. The fundamental requirements and resulting principles follow four intuitive rules. This is a multi-party system, and so a delegation of authority may be between organizations. In other words, it may cross a trust boundary. When this happens, it is not good enough to deploy rules in someone else's software system and trust their system to enforce them. As we have seen, one of DAML's strengths is its flexibility in modeling delegated authority. So the use of an authorization will often be by a delegated agent in another organization. Furthermore, that delegated decision may mean authorizing a third party to contribute to the workflow in some way, and with everyone involved belonging to different organizations. Therefore, it is necessary for a party that grants an authority to be able to observe the use of that authority and verify that its subsequent use or further delegation is correct and within any limits and conditions set upon the initial grant. To achieve this, a party needs to know how its authority is used and to verify it is used within the parameters they specified. A complement to this is when some decision revokes an authorization. This can be as simple as revoking a permission previously granted or more complicated, such as making a mutually exclusive offer to multiple parties that is only valid for the first to act. In this latter case, I might make the offer, but I am not the one who revokes it. Instead, it will be implicitly revoked for all parties by the first party to take up the offer, who will often be in a different organization from me. It is clear that regardless of how it was ultimately granted and revoked, I have a need to know that these authorization changes were valid and correct. Therefore, a party granting an authority to act must have the right to verify that the grant was revoked validly. There are often parties who have an explicit need to know about an authorization. An obvious example is the recipient of the authorization. However, this could also be a notary, a regulator, a market operator, or just another party with an acknowledged interest in knowing what has happened. Of course, this may cross a trust boundary. In some cases, it is required that they be in a different organization. So they also require not only a right to be informed, but a right to verify what happens. Therefore, along with the previously discussed parties who have an implicit need to know, a party may be granted an explicit right to be informed and verify a grant of authority to act, and any eventual revocation of that right. Finally, there can be an explicit right to observe the specific use of an authorization. For example, if a client has been granted the right to conduct trades via a master services agreement, an auditor or regulator probably needs the right to observe not only the authorizing MSA, but also each individual use of this right, and so this will need to be included in the model explicitly. Therefore, a party may be granted an explicit right to be informed of a specific decision should it be made. DAML supports these four need-to-know principles using the concepts we have already looked at: signatories, contracts, choices, and one new concept, observers. Let's look at how each of these principles is modeled in DAML. You have a need to know how any grant is used. A party needs to know how its authority is used and to verify it is used within the parameters they specified. In DAML, this means that all signatories are always informed of the full details of any contract they are a signatory to and the full details of any choice exercised on that contract. You have a need to know about any revocation. A party granting an authority to act must have the right to verify that the grant was revoked validly. In DAML, this means that all signatories are always informed of the full details of any archive of a contract. Explicit stakeholders have a need to know about the authorization. A party may be granted an explicit right to be informed and verify a grant of authority to act, and any eventual revocation of that right. In DAML, this means a party may be designated a contract observer, granting an explicit right to be informed and verify the creation and archival of the contract. Explicit informees have a need to know about a decision. A party may be granted an explicit right to be informed of a specific decision should it be made. In DAML, this means a party may be designated a choice observer, granting an explicit right to be informed of any exercise of the choice. The specifics of how to specify these in a DAML model are covered in the Contract Developer course. When analyzing a workflow, we just need to keep 3 things in mind. Signatories see everything that happens with a contract, as they have a need to know of their authorization grant, every use of that authorization, and the details of its eventual revocation. Choice observers see everything about a specific choice when it is exercised, as this makes them an explicit informee of any exercise of the choice. Contract observers see the creation and everything about the archival of a contract, as they have been made an explicit stakeholder in the authorization grant represented by the contract. Now we have all the pieces to represent decisions and the workflows they drive in DAML. An available decision, through a choice on an active contract, a decision being made by an exercise on an active contract, the authorization required to make a decision, which are the signatories on a contract, the consequences of the decision, represented by the creation and archival of contracts, where contracts are created that authorize new choices by new controllers or assert an authorized consensus on the state of the business, and contracts are archived that revoke authorization for choices by their controllers or reflect a change in that consensus. Finally, we can recognize who will be informed, specifically, signatories on the contract on which the choice was exercised, parties explicitly nominated to be informed of the exercise of a choice, and parties explicitly nominated to be informed of creation or archiving of the contracts affected by the choice. Returning to our original objective, to design a workflow, we now have the foundations for doing so in DAML. We start by identifying a key decision in the workflow. This decision becomes a choice. Then we determine who made the decision and what role were they fulfilling. These become a user and the controller party, respectively. This choice will exist on a contract, so once we determine who authorized the decision, we know who signed the contract. Within the contract and the choice, the controller and the signatories will be parties representing the role they fulfill in the workflow. Next, we look at consequences, making sure we identify what decisions are enabled or become authorized by this decision. Each of these will become their own choices, with their own authorization and their own consequences. We also identify what has changed about the party's understanding of the state of the business as a result of the decision. This will eventually need to be reflected as contracts to be archived and created. Finally, we make a note of any additional parties that have a need or right to be informed of either the decision or any of its consequences. Answering these questions provides us with a comprehensive understanding of this key decision, which leaves only one final question to answer. What was the previous decision that enabled or authorized this one? This decision becomes a preceding choice in the workflow, and so we will repeat our analysis for this new choice and every other choice we discover through the process. If we continue repeating this process up the workflow until we can find no more decisions left to analyze, then we will be left with a comprehensive understanding of the entire workflow. Importantly, this analysis will include the extra detail required to capture the distributed requirements of a multi-party business workflow, and does so in a way that will allow you to take full advantage of the DAML platform.